There's some things we need to talk over before we start today's lesson, just as a matter of review. And when I show you what these things are, I'm afraid you're going to question my sanity, but I don't care, because if I don't show you these things now, I'm afraid we're going to mess up today. Okay? Even the stuff that I show you now, I'm afraid we're going to mess up today, unless we're careful. Okay? 2x equals 6. How do I solve for x? Why would we divide by 2 on both sides?
We have to have x by itself.
We have to have x by itself, and what's the 2 currently doing to the x? It's multiplying, so we have to do the inverse operation of that to get the x by itself, right? And the inverse operation of multiplication is division. Okay so far?
Yes, ma'am.
Okay. What about, we'll just start even simpler than that, and we'll say this. I know it seems weird, but I promise it will come into play today. Why are we going to subtract 3 from each side? The 3 is adding to the x, and I need to do the inverse operation of that to get x by itself. Okay? What about that one? Does it look like I can add the 2 and the 3?
Because they're not like terms.
No, I know they're not like terms, but does it look like I can add the 2 and the 3?
I mean, yeah.
It kind of does, right? Because the very first thing you see is 2 plus 3. OX, right? Okay? So, if it says 2 plus 3, you can't automatically do that. You have to look at what's going on in the problem first. And what's going on in this problem is 3 is multiplying by x. So that term right there is the term I need to get by itself so that I can eventually get the x by itself. Find the x, see what's being multiplied or divided by the x. That's the term you need to get by itself first. Yes? So, yeah, we're going to do that, and so on, right? Yes? So here's the tricky part for today. What would you normally want to do first? We would multiply those two things together. We would distribute the 2 with the 4, multiply, right? Which is fine. We're allowed to do that, right? You get 8x equals 17 and divide both sides by 8. But what if it was like this? Can I multiply the 2 and the 4? No. Why not?
The exponent.
4 has an exponent on it, doesn't it? I cannot multiply the 2 and the 4 because the 4 is a base of this exponent of x. Okay? Please be careful of that because that's going to come into play today. I know you're used to multiplying when there's parentheses like this, and you can over here in a linear function. Exponential functions, we cannot do that. Okay? So let's start right here where it says summary. The common logarithm function on a calculator can evaluate logarithms in base. What? What base can the calculator do? Base 10. You remember that? Okay. We have to put a star by this statement right here. Because it says it cannot evaluate logs for bases such as, and what it wants us to write is 2 and 0.8, because that was problems up here that we did not talk through. But that's a problem. Okay? Because our calculators can do logs with bases of 2 and 0.8. So we have to have a very quick discussion about this. Okay? I don't know where you're going. Juniors, I know where you're going. You're going to either Mrs. Clower for pre-calculus or to Mrs. Cole for statistics, right? Okay? Because you got to have a math next year, right? If you want to graduate on the recommended plan, not recommended, with the endorsements, right? That's what we're going to now. But the rest of you, seniors, I don't know where you're going. And seniors, even if I know what college you're going to, that still doesn't help me. Okay? According to my TEKS, the state tells me, the stuff the state tells me I have to do, I have to teach you how to do stuff like this on the calculator. Everything we do this year has to be taught with technology using a calculator. Okay? I don't remember if those are the exact words that it says, but it's pretty close to that. Alright? But then you get to college, and some college algebra teachers will not allow you to use a calculator. They say, we think they should know how to do stuff without a calculator, by hand. Well, so do I. I taught you that way. Everything that I taught you to do on the calculator, I first taught you to do without a calculator. Remember those times you were mad at me? Because you were like, oh my gosh, it's so much easier with a calculator. Well, I know that, but I still think you need to know how to do it by hand because of the math that goes on in your brain. Okay? The problem is some professors still think that and won't let you use a calculator at all in their class. So you have to know how to do it by hand. Well, we took care of that part, right? But there's some things in logarithms that I have to teach you. Some of them you can do even like on your phone. Okay? You know, you have that calculator that the calculator that goes this way, and then if you flip it, you have the calculator that goes this way. You all knew it would do that, right? But even on your calculator, look what it will do. Log base 10. And that right there, ln, that's log base e. Okay? Now it doesn't say log base e, does it? Oops, I pressed e on accident. It doesn't say log base e, but it says ln. ln means natural log. So you see, in French, you would say log en natural. So ln. I really don't know if that's real. I completely made that up. Okay? I don't know why it's ln when it stands for natural log, but it does. Okay? So your calculator, your phone calculator will even do two kinds of logs, but it won't do things like log base 2 or log base 0.8, will it? No. Okay? So I have to be able to teach you ways around, even though the way our calculator will do it for us, so easy. I have to make sure you know how to do it both ways. Fair enough? Okay. I will show you the easy way. I promise I will. Okay? But they work on our calculators. And here's the deal. Our calculators wouldn't always do this. And I'm not talking about the calculators like when I was growing up, you know, right after the dinosaurs died off. I'm talking about calculators like 3 or 4 years ago wouldn't do this. It's only these newer calculators that can do log base of something else. Calculators is only as smart as the users or the programmers, and the programmers have figured out how to calculate or how to program different bases in there. Had room for it, stuff like that. Okay? So let me show you how we're going to do this stuff, and I'm going to show you both ways. I'm going to show you how to do it the long way, and I'm going to show you the shortcut. Fair enough? So let's start here. 2 to the x power equals 20. So first thing I want you to do is to take the log of both sides. What does that mean, take the log of both sides? You know how like on these previous problems we did divide both sides by 2 or minus 2 to both sides. Why are we allowed to do that? Because we're doing it to the same, we're doing the same thing to each side. We're not changing the value of the equation, are we? So here we're going to apply the operation of a logarithm to both sides of the equation. So we're going to write log of 2x, 2 to the x equals log of 20. Now, what base of log did I take? 10. Accidentally or on purpose? Like really on purpose, right? Because that's one of the logs that even your simple phone calculators can use, right? okay, or can do. So what happens here? What happens with that x? Remembering our properties from the last couple days, doesn't it come down in front as a multiplier? Okay, because the rule is exponents on the argument are the same as the power times the logarithm. So I have x log of 2 equals log of 20. Okay so far? Okay. How do I solve for x now?
Subtract.
Yeah, why would I divide the log of 2 instead of subtracting the log of 2? It's multiplying by x, isn't it? So if I divide log of 2 on both sides, please, please, please be careful at this point. Let me tell you what some crazy kids have tried to do today. Some crazy kids said, well, if the log of 2 over the log of 2 equals 1, doesn't the log of 20 over the log of 2 equal 10? What did I say? Logarithm, remember, is an operation on a number. I'm doing something to the number. I can't just cancel stuff out. Yes, log of 2 divided by log of 2 is 1 because it's exactly the same thing dividing by itself. Okay? But log of 20 divided by log of 2 doesn't automatically mean I can simplify the 20 and the 2. Alright? And in fact, all I have to do from here is take my calculator. Now I want you to watch what I push. Watch what I push, please. Log of 20 excuse me, divided by log of 2. Excuse me. What base am I using here? How do you know that? That's the log we took on purpose, right? Goodness. Did I put it in there? Why do I not have to put it in there?
Because it's,
The calculator knows it, that it's base 10, right? Watch what happens when I press enter.
why did it do that?
Why did it do that? It's telling you that it knows for sure that it's base 10. It's like a reminder to both of you. Did you mean base 10? Because if you meant base 10, then this is what we get as our answer. Okay? Now, chances are, if you did this in your calculator that you have on your desk, you got something different. And that, I mean, 4.32193 is probably what you have.
Yep.
Okay? Because I have my calculator set to go to 12 decimal places, and I think yours is set only to go to 6. Okay? And that's okay, either way. I just wanted to make sure that you understood that those were the same kinds of things. Okay? So I get x equals 4.32193. How would I check that?
Put it in.
Where? Where would I substitute it in? Right, way back up here, right? So 2 raised to the 4.32193 should equal 20. 2 raised to the 4.32193. Again, because mine has going to 12 decimal places, mine might say something different than yours. But is that close enough to say that the answer is 20? Why is that close enough to say the answer is 20? Because I rounded. That's exactly right. Okay? So is this the right answer? Yes. Okay? Look at number 5. First thing it wants you to do, first thing it asks politely, rewrite in logarithmic form. How do I rewrite this problem in logarithmic form? log base 6 of 104 equals x. Most of us are getting pretty good at going from exponential to logarithmic, and that's good because that needs to be a skill that we have. Okay? Now, part B, solve the original equation algebraically. So how are we going to solve this? Well, they gave you some hints. First of all, you got to take the log of both sides, right? When are you going to know that you have to take the log of both sides? Yep. When the variable is in the exponent. That's how you're going to know. Okay? So if I take the log of both sides, I get log of 6 to the x power equals a log of 104. What happens to the x? Goes in front. And I get x log of 6 equals the log of 104. And then to get the x by itself, I would divide both sides by log of 6. So I ended up with log of 104 divided by log of 6. So I'd have the log. Oh, let me show you this real quick while I'm at it as well. I'm going to go ahead and put 10 in there because I don't really trust the calculator to give me the right answer, to just like guess. So I'm going to tell it log base 10. You okay with that? What was it, 6?
You get the same thing.
Huh, you get the same answer. Just giving you a little bit of proof so you can see it. Okay? So let's say x is 2.5921. You okay with that? Any questions? So now let me show you the trick. It's not magic. It's just that the fact that the calculator is built this way. Log base 6 of 104. Bam. Are they the same?
Of course.
Yeah.
Yeah. Well, yeah.
So what are you going to put, 2.6?
No. I mean, I'm showing you that these two ways, this quote-unquote long way, even though it's not really long, this is the way you might have to do it as opposed to this way. Because see, what this way is actually having you do is actually having you use something called the change of base formula. You're having to change the base to a base that the calculator is familiar with, which is base 10. Okay? And look what's next on the sheet, the change of base property. The change of base property says log base b of n is actually log of n over log of b. Isn't that what we did up here? N would be, if I rewrote this, n would be 104 and b would be 6. So it would need to be log of 104 divided by 6. But that's what I got, isn't it? When I did it this way. Okay? So let's pretend we have to use the change of base formula because maybe we forgot our calculator at school, or maybe we don't have one at home and all we have is our phone. Okay? So how would I rewrite this problem to use the change of base formula? Log of 32 over the log of 8. Whoa. That's pretty funny. Oh, go away. So log of 32, is that what I said? Divided by log of 8. 1 2/3. Or 1.6 repeating. Right? What about this one? How would I write the change of base formula for this? Very good. Log of 1 over 49 divided by log of 7. So I could say 1 divided by 49, and then the log of that number divided by the log of 7. Whoa, -2? Is that something I should have been able to figure out myself? What if I rewrote this in exponential form? 7 to what power equals 1 over 49? 7 to the second power equals 49. What do I have to do to the exponent to make it 1 over 49? I have to make a negative. Okay? Any questions about that? I like these directions up here. Rewrite each expression below using only common logarithms. No. Okay, look at 17. This is graphing using that strategy. Guys, if you have a graphing calculator, it's probably going to do a different base for you. But just in case, we'll do one to make sure you know what to do. How am I going to rewrite this, number 17, so that the calculator will graph it for me if it's a dumb calculator? Log of x plus 4 over log of 2. Done. Questions? Okay. Look at number 20. We're actually going to take the time to do number 20. Why are we going to take the time to do number 20? Because it's an inequality. Okay, there's another step that we have to do here. All right? We're gonna do a calculator that we know will work, like the ones we're using right now. So in y1, we're going to put log base 3 of x plus 5. And for y2, what are we going to put? 2, right? The other side. One side of the equation goes in y1, the other side of the equation, or in this case, the inequality, goes in y2. All right?
So it would just be 2.
Yep, just the number 2, because that's all that's on the right-hand side. So I'm going to transfer my graph from my calculator up here on the screen. Understand that I'm a human, and it'll look something like that. Ish. It's pretty close. Okay? When we're solving equations by graphing, or in this case, solving inequalities by graphing, what are we looking for? Exactly, the point of intersection, right? Where they cross. I'll go ahead and tell you that where this one crosses is at 4, 2. I know you could figure that out if I needed to. That's something we've already done, and we're not going to take this second to do that. Okay? 4, 2. So what it's asking you then, it's saying, please help me out by telling me where the log, which you know is the curvy graph, where is that less than 2, which is the horizontal line? Well, can you tell it's this part right here? Yes? So which x values does that cover? Well, what x value does it start at right here?
4.
At 4, right? So basically it's everything less than 4, isn't it? Because it's everything below the line, so it's everything to the left of that point, isn't it? So is that enough of an answer? Is that a good enough answer? So tell me about negative 8. Isn't negative 8 less than 4? Is it part of my solution over here? Will this logarithmic graph ever get over to negative 8? Why not? What stops it from getting that far? An asymptote. Remember?
Asymptote.
There's an asymptote right here, somewhere. Where is that asymptote? Well, you can figure that out by your transformation rules. You can look at the equation and tell me how far the graph has shifted left or right. How far is this graph shifted? Left 5. So how far over is the farthest it's going to get? Negative 5. That is my solution. Does that make sense? Okay. So look at 21. Let's do this one real quick as well. What's going to go in y1? Log base 2 of x minus 2. And what's going to go in y2? Yes, ma'am. 2. Because that's the other side of the inequality, right? Okay? So I'll show you what the graph looks like. There's a horizontal line at 2 again. And then there's this curvy looking line like this. And they intersect, the point they intersect at is 6, 2. Now we have to be able to read what we're looking for. The inequality says the log is greater than or equal to 2. Where's the log greater than or equal to 2? It's above the line this time, right? It's this part over here. What x values does that take into account? Everything greater than 6, right? Okay, so is there an asymptote we have to take into account? There is an asymptote, isn't there? We know it shifted right 2, so there's an asymptote right here, but do we care about that asymptote? Because we're talking about everything to the right of the intersection, aren't we? Or above the line y equals 2. So that's all of our answer this time. Okay? Any questions? All right, look at the back of this worksheet. The back of this worksheet, I'd like you to please circle number 22, 25, 27, 29, and 30. Those are the 5 problems that I need you to do for homework tonight. That leaves you 5 bonus questions on the back. Extra credit questions. 1, 2, 3, 1, 2, 3, 4, and then the one that's actually called a bonus, 5. All right? Any questions about any of these? You have a little bit of time before the end of the period. You can work on these. If you have any questions, please ask before you leave. Other than that,